Hello, ladies and gentlemen. Okay, so it's time for me to give you some video solutions to the density packet. All right, I know some of these questions were very involved. Okay, a lot of calculations, a lot of text to read. Okay, you have to make sure that you don't get intimidated by a lot of things to read. There's just a lot of information you have to put together with some of these, and these are actual Regents questions. So when the Regents rolls around, whenever that time comes for you guys, you're going to need to be able to deal with questions like this. Okay. So I'm going to start off with number one. I have a bunch of questions here. I'll probably do it in a series of videos. It'll just be too long to put into one. But anyway, so we'll do number one first. Okay, so number one, these trees. Okay, these are cylindrical. Okay, you think of a trunk of a tree, it's a cylinder. Okay, um, so here we have a cylindrical. Okay, we want to know how many trees must be sold to raise at least $50,000. All right, so first thing they tell you is the diameter is 50 centimeters. Okay, well, if the diameter is 50 centimeters, we know any of these circular formulas require the radius, so the radius is going to be 25. Okay, so the radius is 25 of our cylinder. Now that's also in centimeters, okay, which we're given the density per cubic meter. Okay, so we have to do all of this in meters. Okay, so 25 centimeters is 0.25 meters. That's what we're going to need to use for the radius. Okay, so I need to find the volume of a tree trunk. Okay, so the volume equals pi r squared h, okay, which is going to be pi times 0.25 squared, okay, and then by 10 meters. Okay, so this is a quarter of a meter, that's the radius, squared times 10. That's going to give me every tree trunk is 1.963 cubic meters. That's one tree trunk. Okay. So this thing tells me its density is 380 kilograms per cubic meter. All right. So if I take 1.963 meters cubed and I multiply it by 380 kilograms, that's going to give me the total mass of one tree trunk. Okay. And that's going to give me 746. 746, 745.94, 745.94. So I'm just going to say 746. Okay. Um, so that's the mass of one tree trunk. Okay. Well, I know that I want to raise $50,000 and it's 475 per kilogram. So that's going to tell me how many um, how many kilograms do I need to raise $50,000. So I'm going to take 50,000. I'm going to divide it by 4.75, and that's going to tell me that I need 10,526 kilograms in order to raise $50,000. That's how much 10,526 kilograms would be worth. Okay, it would be worth uh, $50,000. Okay. Well, now I need to take that and figure out, well, how many trees is that? Well, if there's 746 kilograms per tree, I got to take 10,526 and I have to divide it by 746. Okay. And that's going to give me 14.11 trees. Okay. So I need a total of 15 trees because 14 wouldn't quite be enough. I need a little more than 14. So 15 trees is your answer for that one. 15 trees. Okay. So that's how that one goes. Okay. That's number one. Number two. Okay. Let me get rid of some of this. That's encroaching on my space here. I'm going to delete that. Uh, okay. Now, contractor needs to purchase 500 bricks. Okay. Again, we have mixed units. I said you got to be careful of mixed units. Okay. In this case, the bricks are given in centimeters. Okay. Centimeters. Okay. But the density is given in meters cubed. So I need to do this in cubic meters. Well, I know that 5.1 centimeters is 0.051 meters. I have to divide by 100 to get the number of meters. Okay, if I had 1 centimeter, that would be 1/100th of a meter, 0.01 meters. 2 centimeters would be 0.02 meters. Okay, so this is 0.051 meters. Okay, 10.2 centimeters equals 0.102 meters. Okay, and 20.3 centimeters equals 0.203 meters. Okay, so they're rectangular prism bricks. Okay, so I'm going to multiply all three of these numbers together to get the volume of one of the bricks. When I multiply those three numbers together, I get the volume of one brick is 0.0011056 cubic meters. Okay, that's the volume of one brick. Okay, well, the mass, or I should say the density of each brick is 1920 per cubic meter. So I take that number, 0.01056 times 1920, and that's going to give me the total mass of each brick. That's going to give me, each brick is 2.028 kilograms. That's each brick. Okay. And I want to know, can the trailer hold the weight of 500 bricks? So if I multiply that, 2.028 times 500, I get 1,014 kilograms. Okay. And it can only hold 900 kilograms. So no, the truck cannot carry the weight of 500 bricks. Okay, so that's how that one works out. All right, so that's numbers 1 and 2. What else do we have? Number 4 was the next question people asked about. So let's take a look at number 4. Okay, this deals with population density, which I mentioned in the notes. If I go back to the notes over here, okay, population density right here is number of people per square mile is population density. Okay, people per square mile. Okay, so in this case, it gives me the number of people and the population density. Okay, if density equals people per square mile, okay, and I have the this is the area, square miles. I know that the area is going to be the number of people divided by the density. Okay, look at that, and this is the area. Okay, so that's what I'm going to do. I'm going to take the people, the population. So I'm going to take 18,801,310. I'm going to divide that by 350.6, and that's going to give me 53,626. 53626. Okay, that's going to be the area. That's square miles. Okay, miles squared. Okay, that's square miles there. All right. For Florida. Okay, now I got to do just the rest of these. Okay, the same thing. Population over the population density is going to give me the area. Okay, and then when I put them in order, I will get that the choice is number 1. Okay, so I'm finding the area given the population and the population density. Okay, just kind of working backwards with that formula. Okay, so that's that one. Okay, number 5. Let's see, number 5. Okay, so again, this is really a two-dimensional example where we have population, in this case bacteria, over a certain area, which is the surface area of the petri dish. Okay, so they gave us the diameters of the petri dish. Petri dish A has a diameter of 51. That means it has a radius of 25.5. Okay, this one has a diameter of 75, so its radius is 37.5. Okay, we're trying to find which of these has the greater population density at the end of the first hour. Okay, so again, from the notes, population density is the number of people, in this case, the number of bacteria, divided by the area over which it's distributed, the area of the petri dish. So it's number of bacteria over the area. So when I go back here, for A, it's going to be the number of bacteria over the area, which is pi 25.5. That's pi r squared. That number is going to be 19.58. That's 19.58 bacteria per square millimeter. Okay, bacteria per square millimeter. Okay, for B, it's going to be 72,000 divided by its area, which is pi 37.5 squared, and that number is going to be 16.25 bacteria per square millimeter. Okay, so dish A has the greater population density of 19.58. Okay, so that's it for the first 4. Okay, so I'm going to cut this video short now, and then I'm going to come back to go over the rest of the questions on here. All right, so see you next time.